Good evening, everyone. This is Unit 6 of IEL Chemistry from June 2020. This session, I'll discuss question 3 and 4. A group of students carried out experiment to determine the determine rate equation for reaction between bromide and bromate 5-ion in acidic conditions. The equation for this reaction is shown. The procedure is there. The 10 cm cube of phenol solution in a boiling tube. Add 5 drops of methyl red indicator. Then the mixture turned yellow, the alkaline colored methyl red, and then 5 cm cube of potassium bromide and 10 cm cube of sulfuric acid to a boiling tube. The mixture turned red, the acidic color of methyl red. Then 15 cm cube of aqueous potassium bromate in a second boiling tube. Mix the content of 2 boiling tubes and start the timer. Record the time when the color of methyl red is bleached from red to colorless by excess of bromine. So when excess of bromine is there, it will decolorize methyl red. Repeat the experiment using different volumes of potassium bromide, adding distilled water so that the total volume of a reaction solution is always 40. Two hazard warning signs are for phenol. This is showing it is corrosive and toxic. State the most important hazard associated with phenol in this experiment and the precaution. So in this experiment, because we are adding a phenol to a boiling tube and then transferring. So most effective one is that it will be corrosive. And how we can, the safety precaution for when it is corrosive, so we can wear gloves. For the next part, explain the purpose of the phenol in this experiment. So what is the purpose of the phenol in this experiment? First, phenol will react with bromine. So phenol will react rapidly with bromine. So when the bromine initially it is formed, it will not decolorize the methyl red. Why? Because the bromine reacted rapidly with phenol. And when all the phenol is used up, the remaining bromine will bleach the methyl red indicator. Otherwise, what happen if we were not having a phenol? Instantly the bromine produce and it will decolorize methyl red indicator, so it will not be accurate because in a short time it will decolorize methyl red indicator. Suggest a way of suggest a way of making the disappearance of methyl red color easier to see. So we can use a white background, so it will be easy to recognize. A student results are shown. So he's changing the volume of uh, bromate bromide ion, and sulfuric acid. He kept it same, but the total volume of a solution is 40. When you add the total volume, volume added to 10 cm cube of phenol. So total volume is 40. Suggest why the total volume of a mixture is kept constant. So what is the reason why when we keep the total volume same, in that case the volume is proportional to concentration. So that volume proportional to concentration. What does it mean? Volume proportional to concentration. It means the one which is having greater proportion or greater volume in the mixture will have a higher concentration in the solution. So we can work out the change in the volume as change in concentration. Plot a graph for reciprocal over time against the volume of bromate 5 solution. So we have reciprocal over time 1 over T. Basically what happened, the concentration, because we know rate is equals to concentration divided by time. So we are plotting for volume. If we increase the volume, it means we are increasing the concentration. So what happened to the value of the time? The reaction will complete in a short time. If a reaction complete in a short time, because the rate will increase and rate and time are inversely proportional. So if rate increase, time interval will decrease, but 1 over time will increase. So if we sketch a graph for 1 over T and the volume, so what it should be from the result, it should be a straight line. Then suggest the order of a reaction with respect to bromate 5 ion and justify your answer. So how we'll work out? If it was a first order, then the time interval, like if the concentration is double, the time will be half and 1 over time will also be double. So using our graph, when we plot a graph, we will use a graph and find the gradient. The gradient will be constant here. So if the volume is double, the concentration is double, and concentration is double, the rate will also be double or the time will be half. So but we will use a graph here. So as you can see, even you can use a graph or you can use a table here. If you compare the concentration of a bromate ion, so if the concentration is half, this is time interval, time for the reaction to occur. So this is 15, this is 8. Approximately, or you can take this value. This one is divided because you have the volume 15 and you have the volume 16. So what is the change? The change in the amount. So it will be 15 divided by 6, which is 2.5. So this is divided by 2.5. And when you check, this one is 40 multiplied by 2.5, which make 100. So if the concentration, so if time is increased, but what happened to rate? Because rate is reciprocal of the time. If the time is increased by 2.5, the rate will decrease by 2.5. So rate also decreases with the same manner as a concentration or the volume. So it is first order with respect to bromate. Reciprocal time 1 over t is used to measure the rate of this experiment. Suggest an assumption on which this depends. Refer in your answer the shape of typical graph of reactant concentration and time. So if it is a first order, then it will have a constant half-life. In the beginning we have maximum concentration, and with the passage of the time the concentration decreases. So this will be concentration and this will be time. And what is our assumption here? What we consider? We consider that the methyl orange, which is decolorized in the reaction when the concentration of a reaction versus time, it is almost a linear change. Practically it will not be a linear change, like, because if concentration is high, it will take a short time. So when we consider that methyl orange, which is decolorized early in the reaction, when the concentration of the reactant versus the time is a linear change, so that the gradient will be same for concentration and time. Another student accidentally measured 8.5. So if he accidentally measured 8.5 rather than 8, explain whether or not the proportion of bromide he should not discard, because we need the total volume to be 40 cm cube. So the total volume of the solution to be 40 cm cube, 10 cm cube of phenol is there, 10 cm cube of phenol is added, and instead of 8 he added 8.5 cm cube of potassium bromate. So what he should do, the change, the volume of water he's adding to make the total volume. So here he was adding 7. So instead of adding 7, how much he should add? He should only add 6.5 cm cube of water. Question 4. A group of students prepared aspirin from 2-hydroxy benzoic acid using ethanoic anhydride. So 2-hydroxy benzoic acid and ethanoic acid anhydride formed aspirin. Compound 2-hydroxy benzoic acid, molar mass is given at melting point, ethanoic acid anhydride and aspirin. Step 1 is there. We measure 2 gram and put in a pear-shaped flask, then 5 cm cube of ethanoic acid, concentrated sulfuric acid, which is a catalyst for this reaction. Then mixture was heated with the water bath using a Bunsen burner. Then continue warming the mixture another 10 minutes. Then removing the flask and 10 cm cube of crushed ice and some distilled water. Then stand a flask in a beaker ice water until no more aspirin crystallizes. Filter off aspirin using a Buchner funnel. Wash the aspirin crystal with minimum volume of iced water so that it will dissolve the soluble impurities, and then recrystallize aspirin. Like, wash the aspirin crystal with minimum volume of ice water and then recrystallize. Why? Because why we use a minimum volume? So that maximum will be crystallized when we do recrystallization. So the first question. So give a reason of placing a flask in a cold water in step 1. Why we place in a cold water in step 1? Because the reaction is exothermic. So exothermic reaction release energy. That's why we normally place them in a cold water. Suggests the purpose of concentrated sulfuric acid. It is used as a catalyst for this reaction. By calculation, show that ethanoic acid anhydride is in excess. So we have the density to show that it is in excess or more than enough. So we have 5 cm cube of ethanoic acid. We'll find the mass. So mass is equals to density into volume. So the density is 1.082 and the volume is given 5. So we multiply, we'll get 5.41. That is the mass of ethanoic acid. Then more anhydrides of ethanoic acid, so moles of ethanoic acid anhydride, which is 5.41 divided by molar mass using a structure, the molar mass 102. So the moles are 0.053. Then moles of 2-hydroxybenzoic acid, it is 2 gram. So this will be 2 divided by 138. You get 0.0149, 1449. And when you check, the ratio between them is 1:1. So we have more moles of anhydride, ethanoic acid anhydride, so it is in excess. One student drew a diagram the operators used for reflux in step 4. Identify 3 errors in the student diagram and assume that the apparatus is clamped correctly. So what are the 3 errors? As you can see, the reflux condenser is sealed. It should not be sealed, that is a mistake. Then water inlets from the bottom, it should be come in, and from top it should go out, so that it will not create an airlock. And you can see we are using a conical flask here, so we don't use conical flask. It should be either a round bottom flask should be there, or a pear shaped flask can also be used. Suggest the purpose of adding crushed ice and distilled water in step 5. So what is the reason why? Basically, what we are doing, we are removing the excess of ethanoic acid anhydride. That is the main purpose. Why we are adding a crushed ice and distilled water in step 5. So you can see the step 5. Remove the flask from hot water bath and add 10 cm cube of crushed ice and some distilled water. So main purpose of this is to remove anhydride of ethanoic acid, because that is in excess. The filtration step 7 is carried out under reduced pressure. 2 advantages of carrying out filtration under reduced pressure. So it will be, dry solid will be there, and it will be faster process. Describe how the purity of recrystallized aspirin could be tested. Experimental detail are not required. So what we can do, we can find its melting point, and it should melt around 136 degrees centigrade. So check its melting point. It should melt around, the melting temperature, it's 136 degrees centigrade. So this was unit 6. Just quickly, I will go through the steps of this experiment so you understand the procedure. So first what we did, we took 2 grams of 2-hydroxy benzoic acid and we put in a pear-shaped flask, then we clamp and suspend in a water bath containing cold water. Then we add 5 cm cube of ethanoic acid. Why it was there in a cold water? Because the reaction between this ethanoic acid anhydride and 2-hydroxybenzoic acid is exothermic. We add few drops of sulfuric acid as a catalyst, anti-bumping granules, and fix a reflux condenser on a flask and warm. So why we are warming them? The main purpose why we are warming them, because so that thoroughly they mix with each other, thoroughly it reacted with each other. That's why. And what is the purpose of this anti-bumping granules? The anti-bumping granules will make sure that it's a smooth boiling, small size bubbles will form. And then remove the flask from hot water and add this. This is to remove excess of anhydride ethanoic acid, then stand the flask in a beaker of ice water until no more aspirin crystallized. So when we will filter off, the aspirin will be there on the filter paper, and then wash the aspirin with minimum volume of ice water so that very small quantity will dissolve, and recrystallize the aspirin using a mixture of ethanol and water. So this one is to dissolve the soluble impurities, and we use ethanol and water mixture to recrystallize aspirin. So this was unit 6 of IEL chemistry from June 2020.